All right, so in the last lesson, we talked about inequalities. So that's not using equal signs, it's using less than or greater than signs. If you did not watch that lesson 6.7, I highly recommend that you go do that before you do this one, just so we can do the graphing really fast after we solve inequalities. This lesson is all going to be about solving inequalities. When we solve an inequality, it's going to be the same process as solving an equation. So to solve an equation, you want to go back to lessons 6.1, 6.2, 6.3. We did all different kinds of solving an equation, but we talked a lot about bed mass. Bed mass is our order of operations, and I like to refer to doing bed mass in reverse. So when we're solving, we actually do bed mass backwards. We start here and we move that way. We also talk about opposite operations. If you don't remember what those are, it's like the operations are like addition and subtraction. So the opposite of addition is subtraction. The opposite of subtraction is addition. With multiplication and division, the opposite of multiplication is division. The opposite of division is multiplication. We do have opposites for exponents. We just don't really talk about it. And then brackets come last, meaning that that's the inside of brackets. Cool. So if you don't remember working bed mass backwards or opposite operations, I highly recommend you go review the lessons 6.1, 6.2, 6.3, 6.4, just so you can see what solving an equation looks like. Because that is how we're going to solve inequalities. Okay, let's start some examples. So we're going to start off by solving. To solve means to get the variable, in this case x, by itself. You also might have heard the terminology isolating the variable. That's the same thing. You're going to get x on one side all by itself. In the past, we always had an equal sign. Now we're just going to have an inequality sign, so something like that, instead of an equal sign. But we're going to treat it like an equal sign. So when we're trying to solve this thing, we're trying to get x on one side of the inequality and all the numbers on the other side. The way that we do that is by using opposite operations and by doing bed mass backwards. So the first thing I want to notice is, okay, x is over here on the left side. So I'm going to move everything away from x. And I'm going to do that by doing bed mass backwards. So I'm going to get anything subtracted from x to the other side first. There is no subtraction. The next thing I'm going to do is try to get any additions away from x. I do have an addition next to the x. I have a plus 8 next to the x. So I want to get rid of that plus 8 first. The way I move things in math from one side of the inequality to the other is by opposite operations. The opposite of plussing 8 would be subtracting 8. So I need to subtract 8 from both sides of the equation. Right, what we do to one side, we do to the other. We balance things in math. So I subtract 8 from the left side. That makes the 8s actually cancel out. And then on the right side, we end up getting, so we have 3x. We still have an inequality sign of greater than. And then 2 minus 8 becomes negative 6. Okay, so the first thing we did was we moved that plus 8, or the addition of 8, to the other side. We now only have 3x on the left side. So as we go through bed mass, we now need to get rid of anything being multiplied by x. This is multiplication. That means 3 times x. The way you move things is by opposite operations. So the opposite of multiplying is dividing. So I'm going to divide both sides by 3. This means on the left side, 3 divided by 3 would be 1. It would cancel out, and I'd have only x. And then I'd have a greater than symbol still. And negative 6 divided by 3 is negative 2. This means my solution is that x is any number greater than or equal to negative 2. As long as x is a number that's greater than or negative 2, it would make this original question actually true. It would mean that 3 times x plus 8 would be greater than positive 2. So our answer is x is greater than negative 2. If we wanted to graph that, negative 2, we are greater than, so it's an open circle, and it's to the right, which means greater than. Awesome. That's solving inequality. So it's actually like almost identical to solving equations. There are some slight differences. So in the next question, we're going to see something that's a little unique. We have this one. We have 8 minus 4x is greater than or equal to negative 12. We're going to try to solve this. To solve this, I'm going to move things from one side to the other. So I have this x here. Ideally, I want to move things to the other side of the inequality. So the first thing I'm going to move is anything that's further away. So this like right here is an invisible plus 8. The opposite of plusing 8 would be minusing 8. So I'm going to minus 8 from both sides. That leaves me with negative 4x is greater than or equal to, and then negative 12 minus 8 is negative 20. If you remember back when we solved equations, I like to talk about do something and then reorganize your work. So I just did something. I moved negative 8 from one side to the other. Sorry, I moved positive 8 from one side to the other. So I did something, and then I reorganize my work. I write what's left over. Then I go again and I try to move another number. In this case, I want to move this. This is negative 4 times x because there's nothing in between the 4 and the x. The opposite of timesing is dividing. So I'm going to divide both sides by negative 4. When I do that, negative 4 divided by negative 4, they cancel out. They actually equal 1. Canceling out is not really a thing. It's just the term we use, leaving me with just x on the left side. And then we have negative 20 divided by negative 5. A negative divided by a negative is a positive, and 20 divided by 4 is 5. Now, here's where things get a little bit different for inequalities compared to equations. When you divide or multiply both sides by a negative number, and this is only for negative numbers. So when you divide by a negative number, you flip your sign. So keywords here. When you divide or multiply by a negative number, you flip the sign. This means instead of being x is greater than or equal to 5, it would become x is less than or equal to 5. That's the only thing that's different about solving inequalities versus solving equations is that you need to reverse the sign from time to time, only when multiplied or divided by negatives. If we wanted to graph this final answer, we would draw a 5. We are allowed to equal 5, so we do a circle, and we want to be less than 5. So there we go. Awesome. The reason why we do that, because you can technically solve an inequality like this in a different way. It gets kind of sticky. So I'm just going to show you how this works. But if you don't want to watch that, that's fine. Just fast forward for the next 30 seconds until I get to the next question. The reason why this works. So if I had, let's do negative 4x is greater than or equal to negative 20. Technically, you can move things from one side to the other by adding and subtracting. So I technically could move this 4x by adding 4x to the other side. And that would give me 0 is greater than or equal to negative 20 plus 4x. And then I could technically move that 20 over by adding 20 to the other side. That would give me 20 is greater than or equal to 4x. And then I could divide both sides by 4. When I do that, I end up getting 5 is greater than or equal to x, which you'll notice is the same thing as this, but it wouldn't have been if we hadn't flipped the sign, right? So that's why you have to flip the sign, because if dividing a negative is the same thing as if you were to rotate sides and add and subtract things to the other side. It's just a much longer process. So instead of doing it this way, the long way, what we do is this way, and we just flip the sign. Awesome. We're going to try another example. So if you're looking at this one right here, I want to get x by itself. I'm going to move the 25 first because it's further away from the x. So I'm going to subtract 25 from both sides. After I do something, I rewrite my work. So on the left side, I have negative x, 8x still. It's less than. Negative 31 minus 25 is going to be negative 56. So I move the 25, I reorganize my work, and now I'm going to divide by negative 8. On the left side, negative 8 divided by negative 8 would give me x. They would equal 1, they cancel out. Instead of less than, it is now a greater than symbol because I divided by a negative right here. So I flip my sign. And then negative 56 divided by negative 8 is positive 7. So my answer to this is x is greater than 7. Over here, if I wanted to graph it, that's 7. I want to be greater than 7. So I do an open circle because I can't equal 7. And I go to the right because I'm greater than 7. Awesome. D. D has x on the right side, so it's a little bit different. But our rules are still the same. We're going to try to get x by itself. To do that, you're going to move whatever's being added or subtracted to it. In this case, we have this invisible plus 20. So the opposite of plus 20 would be minus 20, and I'm going to subtract 20 from both sides. When I move something, I reorganize my work. So 48 divided by negative 20 is 28. I'm still less than or equal to. And then this right here is a negative 1x. So remember, there's an invisible negative 1 there. Right? Negative x. The way you get rid of that negative 1, and it's invisible, is by dividing both sides by negative 1. That causes 28 to become negative 28. It causes my less than sign to become a greater than sign because I divided by a negative, so I flip the sign. And then I get a positive x all by itself. This is my final answer. A lot of people will leave their final answer as this. And they won't deal with that negative sign. You haven't solved until you get x all by itself. This is not x by itself because you need to get rid of that negative. It's an invisible negative 1, so you have to remove it to get this as your final answer. Negative 28 is greater than or equal to x. If we're graphing that, so we have negative 28. We are allowed to equal it, so we do an equal sign with a dot. And we want to be less than negative 28, so we're going this way. Awesome. E. If you look at E, we've got a couple problems here. The first problem is that there's brackets. The second problem is that you have x's on both sides of the equation. So if you remember, we did this with inequalities a long time ago. Our method to tackle this is to get rid of the brackets. The best way we get rid of the brackets is by using the brackets. Remember that brackets mean multiply. So what we could do is we could take this 2 and we could multiply it by distributing it into the brackets. So that's the first thing we're going to do. We're going to get rid of the brackets by multiplying. This becomes 6x minus 10. I got that because 2 times 3 is 6 and 2 times 5 is 10. The x and the negative symbol stayed the same, and that is now greater than 2x plus 6. Awesome. So we've tackled one of the two issues. We've gotten rid of the brackets. The next issue we have is that we have x's on both sides of the equation. When you have x's on both sides of the equation, you need to somehow get them on one side. We do that by moving the x's one way. I like to always move towards the bigger number. So if I have 6 x's over here and I have 2 x's over here, I'm going to move the smaller amount. In this case, 2 is less than 6. So I'm going to subtract the 2x's from both sides. So I'm taking the 2x's, I'm moving them from the right side to the left side, which will give me 6x minus 2x gives me 4x's minus 10 is greater than, on the right-hand side, the x's are now gone. All I have is 6. At this point, you have a question that are like the ones above, so we can do it quick. We're going to add 10 to both sides. That gives me 4x is greater than 16. And then I'm going to divide both sides by 4, giving me x is greater than 4. If you wanted to graph that, we have 4, we're greater than, so we're to the right. Awesome. F. F has brackets as well, so the first thing we want to do is deal with the brackets. We deal with those brackets by multiplying the number into the brackets. In this case, the number is 7. But we remember from our last unit that that's actually -7. So I want to multiply the negative with the 7. The negative is key here. That means I still have a 13x out front. -7 times -2 becomes +14. And then -7 times a plus x, positive times a negative becomes a negative, and then 7x. Make sure if you're already ahead of me that that is a -7x. People forget to bring the negative in with the 7, and then they make a mistake. On the right-hand side, I didn't do anything, so I still have 4x minus 10. Awesome. In Unit 5, we learned that after we multiply, we collect like terms if it's possible. Looking at this inequality, on the left side of the inequality, I actually do have like terms. So I'm going to combine those like terms before I start solving. 13 minus 7 would give me 6x plus 14. And then it's greater than or equal to 4x minus 10. So now that we have this equation, we notice we have x's on both sides of the equation. We have a 6x over here and a 4x over there. So we need to move the x's to one side. I always move whichever side has less. So 4 is less than 6. So I'm going to move the 4 by subtracting 4x from both sides. That gives me 2x plus 14 is greater than or equal to -10. I then can just quickly go minus 14 from both sides. This leaves me with 2x is greater than or equal to -24. And then I can divide both sides by 2, giving me an answer of x is greater than or equal to -12. If we're graphing that, we have -12. I'm allowed to equal, so it's colored in dot, and I'm greater than, so I'm to the right of -12. Awesome. This one, I'm going to do it a little bit quicker. So if I look, I have brackets. I need to get rid of those brackets. So I multiply that -9 in. That gives me 9x minus 2x is greater than or equal to -14. Sorry, +14. -9 times -x becomes +9x. -9 times -4 becomes +36. After I've multiplied, I check for like terms. On the left side of the equation, I actually already had like terms. I had 9x minus 2x. Those would combine to be 7x. On the right side of the equation, I have more like terms. I have 14 plus 36. That would add together to be 50. Sorry, I didn't want that to be in red. So I have 50 plus 9x. Just a reminder that these x's are not like terms, like all these, because one is on the other side of the equation, right? We can only collect like terms that are on the same side of the equation. Awesome. At that point, I need to start solving. I'm going to move all my x's from one side to the other. I usually move the smaller one to the bigger one, so I normally would move that 7x to the right. You could move the 9x to the left if you wanted. So I'm actually going to do that. The reason that might be a benefit is because I noticed that there's no constants on the left side of the equation. So that's kind of nice. So I'm going to move the 9x from the right to the left. That gives me negative 2x is greater than or equal to 50. And then I divide both sides by negative 2. If you worked ahead, let's finish this off. Negative 2 divided by negative 2 cancels out. I'm left with x. I changed the symbol because I divided by a negative. So it's now less than or equal to 25. If you worked ahead and you had this, and you're following my rule of move the smaller number to the bigger number for x's. So if you were like, hey, 7 is less than 9, and you move numbers to the right, this is how it would look. So I subtract 7x from both sides. On the left-hand side, if I had 7 x's and I subtracted 7 x's, I'm left with 0. And there's nothing left there because I subtracted it away. So I have 0 is greater than or equal to 50 plus 2x. Now I need to start getting x by itself, so I'm going to subtract 50 from both sides. That gives me negative 50 is greater than or equal to 2x. And then I divide both sides by 2. And I get negative 25 is greater than or equal to x. These are the same solutions. They're written reverse, but they're the same answer, right? The arrow's still eating the negative 25, and it's pointing at the x. So those are the same answer. If we wanted to graph it, they both graph like this, negative 25. I'm allowed to equal, and I want to be less than. So I'm going like that. Fantastic. You can try this one on your own, H. So I'm just going to go through it quick. You can check your answer. I'll try my best to show my work. So negative 6 is going to come into the brackets to become negative 42x plus 6. And then I have greater than, and I took that 9 and I also multiplied it in. So I have negative 8x minus 27x minus 36. I'm going to collect my like terms. So I do have some like terms I can collect. That leaves me with negative 42x plus 6 is greater than negative 35x minus 36. I move all my x's to one side. I'm going to choose to move these 42 x's because negative 42 is less than negative 35. That gives me 6 is greater than 7x minus 36. I add 36 to both sides. That gives me 42 is greater than 7x. If you ever run out of room, I highly recommend that you just start again, like make a little column and then start on that column. And then divide both sides by 7. And you get 6 is greater than x, like that. If we were to graph that, there's 6. I'm an open circle and I'm greater. Wonderful. I. To solve I, if we look at that, I'm going to still follow my rules of reverse BEDMAS. So I'm going to move any additions or subtractions from my x. I'm going to add 8 to both sides. That leaves me with x over negative 6 is greater than or equal to negative 4. Now, we have this fraction on the left-hand side. Fractions mean divide. Right? This is the same thing as saying x divided by negative 6. And the opposite operation to dividing is multiplying. So I need to multiply both sides by negative 6. We do multiplication with a dot. And what I do to one side, I do to the other. On the left-hand side, those will cancel out, leaving me with x is greater than or equal to, and then, back up for a second. I just multiplied by a negative. Because I multiplied by a negative, I reverse my sign. Remember that. Multiplying by a negative reverses your sign. -4 times -6 becomes a positive 24. So my answer is x is greater than or equal to positive 24. If you wanted to draw this, we are looking like that. Wonderful. That's how you deal with fractions. Okay, so you move things away just like you normally would, and to get rid of a fraction, you're going to multiply. We look over here, we're going to do the same thing. So I'm going to move the 1 over by subtracting 1 from both sides. That gives me 3 is less than x over 7. I'm going to get rid of that 7 by multiplying both sides by 7, leaving me with 21 is less than x. If we were graphing that, we have 21. We're not equal to, so we're an open circle, and x is bigger than that. So it looks like this. Awesome. K. If we look at K, this is a unique situation where we have a fraction where there's multiple things going on in the fraction. The way we handle this, when we have a numerator that's a binomial and it's not a monomial, we pretend that there's brackets around it. So we actually have -10 plus x in brackets divided by 2. We don't move brackets until our last step. So to start this question off, we actually have to get rid of the 2. And the way we get rid of the 2 is by multiplying both sides by 2 so that it cancels. And I now have -10 plus x is greater than -16. So when you have a fraction where there's a binomial on the top, you get rid of the bottom first. And then you're just left with the binomial, and then you can start your process again of moving things away from the x. So we add 10 to both sides. That means x is greater than -6. If you were to graph that, we have -6. It's open circle because it's not equal to, and it's to the right because x is bigger. L. Same idea. I now have a fraction that has a binomial on the top. So before I can deal with that -3, I pretend it's in brackets, and I have to deal with that 4. I deal with that 4 by multiplying both sides by 4. That gives me x minus 3 is less than or equal to 20. Then I can add 3 to both sides. That gives me x is less than or equal to 23. If I'm doing this on a chart, there's 23. I'm equal to it, so it's a solid dot, and I'm to the left, so I'm to the left. Like that. Wonderful. We're going to do 2 word problems. To do word problems, we're going to try to read those words, turn it into a mathematical equation like we've done in Unit 5, and then we're going to try to solve it. So reading this. It says, the student council decides to raise money by organizing a dance. The cost of hiring the video DJ is $1,200, and the student council is charging $750 per ticket. How many tickets need to be sold to make a profit more than $1,500? Graph the solution. Let's start off with what our goal is. Our goal is profit more than $1,500. Mathematically, that means we want to do this. Profit is greater than $1,500. And that's the goal. So I can turn that into a mathematical equation by writing profit is greater than $1,500. Now we need to try to turn profit into a mathematical equation. Profit is when you take what you make and you subtract what it costs. So if we're talking about profit, it equals what you make minus what you spend. What I make is $750 per ticket, but I don't know how many tickets I sell. So what I make is $750 times X. That represents $7.50 times X, where X equals the number of tickets. Because I don't know how many tickets I'm going to sell. I then have to do what I spend. What I spent was $1,200. So profit is what I make minus what I spent, which is $1,200, and we want that profit to be greater than $1,500. Spend is in green, make is in blue. My restriction from the very beginning is in red. Our goal now is to solve this inequality. When I solve this inequality, it means get x by itself, x being the number of tickets. That will then tell me the number of tickets that have to sell in order for my profit to be greater than 1,500. I'm going to do opposite operations. So I'm going to add 1,200 to both sides. When I do that, I am left with $7.50 times x is greater than $2,700. I now need to get x by itself, so I divide both sides by 7.5. On the left-hand side, that'll give me x. On the right-hand side, if you punch 2,700 divided by 7.5 in your calculator, you should get 360. This is my answer. Now, what that answer means, x is the number of tickets. So in order for there to be a profit of 1,500, we figured out that the number of tickets sold is greater than 360. That's what that means. If you wanted to graph it, there's 360. We're open-faced because we don't want to be equal to, we want to be greater than. Word problems like that are very, very challenging. And will take a lot of practice. So make sure you do the practice questions on it and check your answers with the answer key. I'll let you try example 3 on your own. So pause this right now. See if you can just build the equation. Okay, so try that and then look back and see what I did to build an equation, and then we can try to solve together. But check your equation before you solve. Okay, to build the equation, it says Tonka weighs 150 pounds. He's loading a freight elevator with identical 67-pound boxes. The elevator can carry no more than 2,000 pounds. If Tonka rides up with the boxes, how many boxes can be loaded on the elevator? Somewhere in here we got a restriction. The restriction was the elevator can carry no more than 2,000 pounds. That means my weight has to be less than 2,000 pounds. It technically could also be equal to 2,000 pounds because it said carry no more than 2,000 pounds. Then, to figure out your weight, my weight in this case will equal Tonka plus the boxes. We don't know how many boxes there are. So when we do this calculation, the weight will be 150 for Tonka plus the weight of the boxes, which is 67 boxes times however many boxes there are. We don't know that, so we put X. It's also important that you write somewhere what X is. So in this case, I would have to write X equals the number of boxes. I then can solve my inequality. I do that by minusing 150 from both sides. That gives me 67. X is less than or equal to 1,850. I then divide both sides by 67. That gives me X by itself. It is less than or equal to, you punch 1850 into your calculator and divide it by 67, and you get 27.6. It goes on, but we're going to leave it like that. Okay, if we wanted to logically talk about this X is the number of boxes. So we're saying the number of boxes that Tonka has on the elevator has to be less than or equal to 27.6. Now, that doesn't make logical sense, right? Because you can't have 0.6 of a box. So if I asked you how many boxes can be loaded, the answer would be 27. 27 boxes would be fine. The 28th box would weigh too much. So the answer is how many boxes can be loaded? It's 27 boxes. And I had to think a little bit logically about that and realize that even though it's 0.6, I need to round down because the 28th box would weigh too much. The 27th box would weigh enough. If we wanted to graph this, I would then have 27 here. I could equal 27 or be less than 27, like that. Wonderful. Happy practicing solving inequalities.